Question 4. Consider the function f of x. Find the domain of the function. The B part, determine the interval on which f of x is increasing and decreasing. The C part, find the local extrema. Determine the intervals on which f of x is concave up or concave down. So without wasting time, let's go straight to the solution. The domain for this function is going to be all real number. So the domain is minus infinity and positive infinity, all real number. So that's the domain. For the B part, to find the interval on which is increasing and decreasing, there are steps to be taken. The first step is to find the derivative of that function, the derivative of this function. I mean differential coefficient of that function. And that will be equal to, look at your functions. The power 3 will go to the front. So we have 3 times x minus 1. And then the power also minus 1, that's power 2. And derivative of a constant, that's 0. The next step is to find the critical points. And at the critical points, your differential coefficient will be equal to 0. We have for this place, the critical point is x is equal to what? Is 1. So that's our critical points. Then the next thing to do now is to create a table. So the interval is going to be minus infinity. We only have one critical point, so that's 1, then 1 comma infinity. So that will be our interval. Then the test points, we can pick any value between negative infinity and 1. So we can pick 0 here as our test point. Between 1 and infinity, we can pick 2 as our test point. Then the sign of these derivative, f prime of x. If you put your 0 there, that will be equal to, that will be positive. If you put your 2 also there, 2 minus 1, that's 1, that's also what? Positive. So for the sign of f prime, we just want to know whether it's negative or positive. So in this case now, the nature of f now is what? Is increasing, because it's positive. It's also positive here, is increasing. Okay? So we can now go back to that place and answer the question that f of x is increasing. Is increasing on what? On that interval. So is increasing on these two intervals, here and what? And here. So that answered that question. Then find the local extrema. For the C parts, since it is not changing, you can see is what? Positive, positive. Since it's not changing, then there is no local minimum, also no local maximum. So that's that on that C part. Since the sign for f prime is not changing, so we don't have local minimum and we don't have local maximum. So that's that on that. Then the D part, we want to find the, is the f of x, is it concave up or is it concave down? So let's see how to do that. For concavity, we are going to find the second differential of that function. We got in the first differential. The second differential will be this one times this, and then the power minus 1. So we have this for the second differential. Equate this to 0. If you do that, x is also what? X is also 1. Can we put these points to the original function? When x is 1, put it into this place. So we're going to have 1, 1 as inflection points. That's our inflection point. If you want to get the concave up or concave down, you do the second differential. Equate it to 0 so I can get your inflection points. And we're going to use that value also to get the intervals at which the function is concave up or concave down. So we create a table also, as we did for the other one. We create a table, our interval, the test points, sign of the second differential, and then nature of f of x. So the interval is going to be minus infinity, comma 1, and then 1, comma 1, comma infinity. So the test points between here, we can pick 0 also. The test point, we can take 2 here. and then put those values in your second differential. When it's 0, you have negative. When it's positive, when it's 2, put it there. We don't need the value. We just want to know, is it positive or negative? So put it there. 2 minus 1, that's 1. So this one is what? This one is positive. This is positive. Okay? So in that case now, if it's negative, that means it is what? It is concave down. With your function, your sign of second differential, it is positive, is concave up. So that's that on this question. So this concave on this interval, it is concave down on this interval, it is concave up on this interval. So that's that on concavity. I want to thank you for watching this video. If you are yet to subscribe, if you are new on this channel, please click on the watermarks on this video and subscribe. Don't stop there. Click on like button and begin to type your comments. Thank you for doing that. Question 6 continue. Next question, that will be question 5.